The ROV Optimizer is an advanced optimization module that can be used to optimize portfolios and to find optimal investment decisions and optimal project selections for a corporation, a bank, an investment firm, a manufacturer, an R&D outfit, and many others. The decision variables can be discrete, for example 1, 2, and 3, continuous, for example 1.25%, 32.45, and so forth, or binary, for example 0 or 1, for go, no-go decisions in project selection. And the constraints and objective functions can be linear or nonlinear. In addition, Risk Optimizer allows the user to link to existing data tables to run simulations, find the best fitting models, and couple these techniques with optimization. The technical details of optimization fall outside the scope of this quick getting started video. For more details and examples, please see Modeling Risk by Dr. Jonathan Munn, published by Wiley Finance in 2006. We also suggest you click on the File menu and select Examples to load some predefined models to learn how the models can be set up. The ROV Optimizer can handle hundreds of decision variables and can be run at very high speeds. But for our illustration purposes, we will use a simple model instead. And by the way, as you probably realize, our risk simulator software has an optimization module as well. And of course, Risk Simulator works completely within Excel, whereas ROV Optimizer works completely outside of Excel, and hence can be run at a speed that is 100 times faster. We suggest you also review the Getting Started videos for Risk Simulator's optimization module to get a better sense of how optimization is set up and how it works. We will not be repeating the discussions here. In the Methods tab, you can choose from among static, dynamic, and stochastic optimization. Again, please review Dr. Jonathan Munn's book, attend one of Real Option Valuation Inc.'s training seminars, or review the Risk Simulator video segment on optimization for more details of what a static, dynamic, or stochastic optimization actually means. Next, you can click on the Decision Variables tab and hit Add to add some variables. For instance, we have 4 different variables here, assets 1 to 4. And each asset can be set to take continuous, integer, binary, or discrete values. For a simple illustration, set all the variables to be continuous between 10% and 40%, or 0.1 and 0.4. That is, only asset allocation between 10% and 40% are allowed for each of the decision variables. Next, click on the Constraints tab and select Add if you wish. Then the expressions input box appears. Enter in the constraint. You can double click on the list of variables and the variable string will be transferred up into the expressions box. In our simple example, the total decision variable values must sum up to 1, or the total allocation of asset classes must equal 100% in an investment portfolio. Here you can also create an efficient frontier by adding frontier variables if you wish. Again, review Risk Simulator's Getting Started video on the optimization module for more details on frontier variables, efficient frontiers, constraints, and so forth. In addition, if you're using static optimization, you can skip the Statistics tab, whereas the Statistics tab is important if you're running a dynamic or stochastic optimization, when some of the variables are mapped to probability distributions and Monte Carlo risk simulations. That is, simulations will be run before and after an optimization. Next, select the Objective tab and select if you wish to run a maximization or minimization on your objective variable. In addition, you can enter in the relevant objective expression as outlined below. You can double-click on the list of variables to bring the variable name string into the objective expression input box. And when completed, you can click on Verify to test the model if it has been set up correctly, and you can click on Run to obtain the results of your optimization. The optimization results will appear if the optimization model is set up correctly. The results will show the number of iterations, the specific model configuration, the parameters, initial and optimized results of the objective and decision variables, the technical analytics if you wish to review them, including things like Lagrange multipliers, Hessian matrices, and others, and an optimization objective chart. There are also 2 important functionalities in ROV Optimizer available in the File menu, including examples and variable management under the variable menu. The variable management tool allows you to add, edit, delete variables. For example, by clicking on Add, the familiar input parameter mapping tool appears, just like back in ROV Modeler, as you've seen in previous video segments, which allows you to link, compute, paste, simulate, or fit existing data for use in the optimization process. Again, you can link, download, fit, and so forth other different data sets from data tables, data files, or databases. Finally, if dynamic or stochastic optimization is selected, and if the variables have risk simulation assumptions associated with them, that is, if you're running a Monte Carlo simulation, you can then access the Statistics tab, whereby you can make use of the simulated statistical properties to run the optimization on. In our next video segment, we will spend some time looking at something called ROV Scheduler, ROV Portfolio, and ROV Charter.